Alright, let's dive into something truly awesome. We've all heard of Tesla, right? The company that took the electric car from a quirky science project to something you actually want to drive. It all started with a wild idea, to prove that electric vehicles could be better, faster, more fun. But Elon Musk and his team quickly ran into a massive problem, a real showstopper. To build millions of cars, you need millions of batteries. And back then, the entire world's production of lithium-ion batteries wasn't even close to enough. It was a classic bottleneck, a roadblock of epic proportions. So what do you do when the world can't make enough of the one thing you desperately need? If you're Tesla, you don't just find a new supplier. Oh no, that's thinking too small. You decide to build your own factory. A factory so enormous, so ambitious, it would single-handedly double the world's battery production. They called it the Gigafactory, with giga coming from the unit of measurement representing billions. This wasn't just about building a big shed for making batteries. It was a fundamental part of the master plan to accelerate the world's transition to sustainable energy. It was a bet-the-company kind of move, a go big or go home play that could either change everything or fail spectacularly. The vision behind the Gigafactory was simple but profound. Bring everything under one roof. Instead of sourcing battery cells from Asia, shipping them to another continent, assembly into packs, and then sending those packs to a car factory, Tesla wanted to do it all in one place. This concept, known as vertical integration, is a manufacturer's dream. It means you control the entire process, from raw materials coming in one end to finished products going out the other. When we talk about the size of the Gigafactory, your brain has to do a little recalibration. It's not just big. It challenges your sense of scale. The first Gigafactory, located in the desert of Nevada, is a testament to what's possible when you refuse to think small. The building itself is one of the largest on the planet by footprint. Imagine dozens of jumbo jets parked wing to wing, and you're starting to get the picture. It's so vast that employees often use bicycles or carts to get from one end to the other. And the craziest part? The current structure is only about 30% of its planned final size. The layout of the factory is a masterclass in logic and efficiency. It's designed like a giant conveyor belt, a straight line of production. Raw materials enter at one end of the building. They are refined, turned into battery cells. The cells are assembled into modules. The modules are built into massive battery packs. Those packs are then paired with the drivetrains. This linear flow minimizes movement, eliminates wasted time, and keeps the production line humming 24/7. It's the industrial version of a perfectly designed circuit board, where every component is exactly where it needs to be for optimal performance. Step inside, and it feels less like a traditional factory and more like a clean, bright, futuristic city. The floors are polished concrete, the lighting is bright LED, and the air is surprisingly clean. It's a stark contrast to the dark, grimy factories of the past. The space is organized into massive, open-plan zones, each dedicated to a specific part of the manufacturing process. You can stand on a mezzanine and watch the entire ballet of production unfold below you, from giant rolls of metal being fed into stamping machines to the quiet, precise dance of robotic arms assembling delicate battery components. The sheer volume of the interior space is breathtaking. What's truly mind-bending is how the factory is designed to evolve. It's not a static building, it's a dynamic system. As Tesla's engineers invent new, more efficient ways to build things, they can reconfigure sections of the factory floor. They are constantly experimenting, running simulations, implementing improvements. Now for the really cool part, the robots. Walking through the Gigafactory's production lines is like stepping onto the set of a science fiction movie. We're talking about hundreds, even thousands of robotic arms working in perfect harmony. These aren't just simple machines performing one repetitive task. These are highly advanced, multi-axis robots. They can lift, they can turn, they can weld, they can rivet, they can assemble. All with a level of precision and speed that feels superhuman. They look like giant, powerful arms in Tesla red. They move with a grace and purpose that's mesmerizing. They're the tireless workforce that makes mass production possible. They handle jobs that are dangerous. They handle jobs that are difficult. They handle jobs that require mind-numbing repetition. On the body line, you'll see teams of robots swarming a car frame. One robot lifts a side panel into place. It holds the panel with millimeter accuracy. Several others zap it with spot welders at the same time. A perfectly fused seam is created in a fraction of a second. The robots communicate, keeping every action synchronized. This robotic ballet gives each car the same structural integrity and panel gaps. That's a level of consistency hard for humans to match. But it's not just brute force. Many robots handle incredibly delicate tasks. In the battery module area, smaller, precise robots work on individual battery cells. The cells look like slightly larger AA batteries. The robots test each cell. They sort the cells. They place cells into the module's cooling architecture with dexterity. They even do microscopic laser welding to connect the cells. These tasks need a steady hand and intense concentration. The robots perform them flawlessly, thousands of times a day, never tiring or getting distracted. And here's something that might surprise you. Robots work right alongside human technicians. The factory isn't fully automated by design. Robots do the heavy lifting. Robots do high-speed, repetitive work. That frees human workers to do problem-solving, quality control, process improvement. Humans supervise the robot army and maintain the machines. Humans troubleshoot issues. Humans constantly look for ways to make the system run better. It's a powerful partnership between human ingenuity and robotic precision. Building the tools for a sustainable future means doing it sustainably. Tesla designed the Nevada Gigafactory from the ground up to be a net-zero energy facility. The goal is to produce all energy it consumes on site, primarily through a massive solar array on its roof. The building also captures waste heat from manufacturing to heat the facility, and a hybrid cooling system recycles water, cutting consumption by up to 80%. Inside, a closed-loop battery recycling system recovers valuable raw materials, lithium, cobalt, nickel, from old battery packs. These recycled materials are then fed right back into the production line to create new batteries. This reduces waste and the need for new mining, creating a more secure supply chain. By proving large-scale manufacturing can be done sustainably, Tesla is setting a new standard for the industrial world, showing profitability and sustainability can go hand in hand. While famous for cars, the Gigafactory's impact extends far beyond transportation. The Giga in its name refers to the planned annual battery production in gigawatt hours, a colossal amount of energy storage. A huge portion is dedicated to Tesla's stationary energy storage, Powerwall for homes, and Megapack for utilities. These batteries are the key to unlocking renewables like solar and wind. They store energy when the sun shines, then discharge it at night, providing clean, reliable power around the clock. This technology is already transformative. In South Australia, a large-scale battery installation built with Gigafactory products has helped stabilize the local power grid, prevent blackouts, and lower electricity prices.